Okay, so I'm going to solve LeetCode 217 in APL in two different ways. The problem is to detect if a given array has duplicates. And by array here, we mean it in the common understanding of the word as it's used out there in the world. In general, so it just means a list. In APL, it's a bit more than that, but we'll not go into that now. Here's some test data, and this one obviously has duplicates. Um, so we have two different functions that provide most of the functionality that we need in APL. One of them is the unique function. So this is a built-in to APL. It's just this kind of U-looking symbol. It takes one argument and it returns the unique elements. And if we do something, do it on something that doesn't have any duplicates, then we get the same thing, which means we can detect if an array has duplicates by comparing the original array to the unique of that array. And we can do so using a tested function. So contains duplicate, and we're going to assign a function value to this name. And the way we can do this very easily in the APL is using something called a fork. A fork consists of three functions. The two outer functions are applied to the argument, and then the middle function between them is applied to the result of the two outer functions. So the two outer functions that we're going to apply is the unique function and an identity function. So this function just returns the argument unchanged, and this function returns just the unique. And if they're the same, then there are no duplicates, which means if they're different, there are duplicates. And so we have a different from function. Now we can use contains duplicates on these, and this says 0, that's false. APL uses 0 and 1 for false and true. And if we use our test data instead, then it's true. So this is one way of doing it. Another way of doing it is to use a little bit more of an advanced function in the APL called a nubsieve, or you could also call it mark firsts. And what it does is it returns a Boolean list of the same length as the argument, with ones indicating every time we see an element for the first time, and zeros for any duplicates. So we can see here that if we back this up over it, the first time we see a 1, we get a 1. The second time, we get a 0. The first time we see a 3, we get a 1, and so on. And so the question is, are there any zeros, right? Because since the zeros indicate duplicates, then any zeros in the result of this marking the first function would indicate duplicates, and that's exactly what we're looking for. So we can redefine contains duplicate, and again as a fork. This time we're going to have the nubsieve, or the mark first function, on the right. The middle function that's going to be applied to the results is going to be a membership, and then on the left we are going to put a constant function. So we could have put a function here, but we don't actually need to apply any function. We just need a value. So we're asking, is 0 a member of this nubsieve function? And then we can go up and try this again, and that works fine, and that also works. That's all.